Types of matrices. The first one is the row matrix. A row matrix is if a matrix has only one row and any number of rows. Sorry, any number of columns. Any number of columns. It is called a row matrix. Example of row matrix is A is equal to 2, 3, 7, 9. If a matrix A has only one row and any number of the columns is called the row matrix. So here there is only one row and four columns. And the order of this matrix is 1 by 4. Now the next is column matrix. Column matrix. Column matrix is a matrix having one column and any number of rows is called a column matrix. A is 1, 2, 3. Column matrix. Third one is null matrix. Null matrix or zero matrix. Null matrix is any matrix in which all the elements are zero. Any matrix in which all the elements are zero is called a zero matrix or null matrix. A is 0, 0, 0, 0, 0, 0, 0, 0. This is the example of null matrix. This is also the other example of null matrix. Now the next is square matrix. Square मैट्रिक्स. नल मैट्रिक्स में सारे एलिमेंट्स हमारे जीरो होते हैं. In the second case, all this matrix has the order 1 by 1 because there is only one element, so it has one row and one column. So this is the example of null matrix. The next one is the square matrix. So the square matrix in which the number of rows is equal to number of columns. A matrix in which the number of rows is equal to the number of columns is called a square matrix. Example is 2518. Here there are the two rows and two columns. So the order of this matrix is 2 by 2. Both number of rows is equal to number of columns. So we can say this is the square matrix. Now come to the diagonal matrix. Diagonal matrix. The next type of the matrix is diagonal matrix. This is the fifth type of matrices. And in diagonal matrix, all the non-zero diagonal elements are zero. A square matrix. These definitions can be asked in 1 or 2 marks. A square matrix is called a diagonal matrix. A square matrix is called diagonal matrix if all its non-diagonal elements are zero. Example is 1, 3, 4, 0, 0, 0, 0, 0, 0. So it is of the 3 by 3 matrix. The next type of that matrix is scalar matrix. Scalar matrix. In the scalar matrix, all the diagonal elements are equal. It may be 2, 3, 4, and the non-diagonal elements are 0. So this type of the matrix is called the scalar matrix. A diagonal matrix, a diagonal matrix in which all the diagonal elements, a diagonal matrix in which all the diagonal elements are equal to a scalar, say k, is called a scalar matrix. Example of the scalar matrix is if A is equal to 3, 3, 3 and 3, 3, 3 and the non-diagonal elements are 0. So here this is the diagonal A11, A22 and A33. The value of its diagonal is 3. So we can say this type of the matrix is called the scalar matrix. Or a matrix we can say that if Aij is equal to 0, I is not equal to j. So this is one of the example and the other example is -8, 0, 0, 0, 0, 0, 0. This is -8, this is 0, this is 0, and it will be 0. This is -8, 0, 0, 0, -8. If A is a matrix of Aij is equal to n cross n is a scalar matrix if Aij is equal to 0 k. 0 is when I is not equal to j and when I is equal to j. This is the scalar matrix. The next type of the matrix is identity matrix or unit matrix. Unit or identity matrix. Unit and identity matrix. So unit matrix is if the diagonal elements has its unity. One elements is called the unit matrix. A square matrix. A square matrix is called a unit matrix if all the diagonal if all the diagonal elements are unity and non-diagonal elements are 0. So A is 1, 1, 1. This is 0, 0, 0, 0, 0. This. So this position is A11, A22, A33. So it is equal to 1. And B is 1001. Its order is 2 by 2. The next type of the matrix is symmetric matrix. Symmetric matrix. What is symmetric matrix? If Aij is equal to Aj, then it is called the symmetric matrix. So we can say that the position of A12 is equal to A21, A13 is equal to A31, A23 is equal to A32. A square matrix, a square matrix will be called symmetric if for all values of I and j. Aij is equal to Aj. That is A transpose is equal to A. We can take the example of symmetric matrix. This is A, this is B, this is C. If it is G, then it will be G. If it is H, it will be H. If this is I, it will be I. Diagonal elements जो हैं वो डिफरेंट होंगे एंड A12 is equal to A21. This is the symmetric matrix. A13 is equal to A31. Now the next is skew symmetric matrix. The skew symmetric matrix. It is ninth one. Skew symmetric matrix. These definitions are important because these are used in while solving the questions. Skew symmetric matrix is a square matrix A square matrix is called skew symmetric matrix. A square matrix is called skew symmetric matrix if the first one is Aij is equal to minus Aj for all I and j. And the second one is all diagonal elements are 0. All diagonal elements are 0. This is 0, 0, 0. This is minus H, H. This is G, minus G. This is F, minus F. So, in the skew symmetric matrix, the diagonal elements are 0 and non-diagonal elements has its negative. Or we can say if we do the transpose means when we interchange rows into column and column into rows, it is equal to minus of A. A transpose is equal to minus of A. So the next matrix is triangular matrix. As we are talking about the triangular matrix, जैसे कि हम triangular matrix की बात करते हैं, it is divided into the two parts. The first one is the upper triangular matrix and the lower one, and the second one is the lower triangular matrix. So this triangular matrix, it is of echelon form. So the other name of triangular matrix, echelon form. The triangular matrix or echelon form. A square matrix, all of whose elements below the leading diagonal are 0 is called upper triangular matrix. A square matrix, all of whose elements above the leading diagonal are 0 is called a lower triangular matrix. 1, 2, 3, 0, 4, 2, 0, 0, 3. This is upper triangular matrix. And 2, 0, 0, 4, 1, 0, 5, 6, 7. It is lower triangular matrix. Upper triangular matrix and lower triangular matrix. So these are the definitions or the type of the matrices, and this can be asked in the examination. So you have to revise these definitions again and again. Now come to the 11th definition. The 11th is transpose of a matrix. Transpose of a matrix. That as I told you, if we interchange rows into column and column into rows, the new matrix obtained is called the transpose of the matrix. अगर हम rows को column में और column को rows में change कर देते हैं तो वो भी हमारी नई matrix बनेगी, उसको हम बोल देंगे transpose of the matrix. So if we interchange if we interchange the rows and the corresponding columns, the new matrix obtained is called the transpose of the matrix A and is denoted by A dash or A transpose. So is equal to 234105678. If this is A, so it transpose is rows are converted into column and columns are converted into rows. If A is this and A transpose is this. The next type of the matrix is called orthogonal matrix. Orthogonal orthogonal matrix. अच्छा, ये orthogonal matrix क्या होती है? If A into A transpose and it will be equal to I. I is identity matrix. I is identity matrix जिसको अभी तक हमने डिस्कस नहीं किया है. अभी मैं आई बताऊंगी आई क्या होता है, आइडेंटिटी मैट्रिक्स क्या होती है. सो ऑर्थोगोनल मैट्रिक्स क्या होती है हमारी? आई स्क्वायर मैट्रिक्स. आई स्क्वायर मैट्रिक्स A is called and orthogonal matrix if the product of the matrix A and the transpose matrix A dash is an identity matrix. That is A into A transpose is equal to I. A and its transpose if we make the product, and it will be converted into the identity, then we can say that it is orthogonal matrix. The one matrix is left, that is identity matrix. So we are going to do first the identity matrix. What is identity matrix? Identity matrix is a square matrix. A square matrix in which elements in the diagonal are all 1 and rest are all 0 is called an identity matrix. Example of identity matrix is A is 1 0 0 1 and B is 1 0 0 0 1 0 0 0 1. This is the example of identity matrix. Here, identity matrix of order 2. This is the identity matrix of order 3. And this is the identity matrix of order 1. So, in the orthogonal matrix, if we do the product A into A transpose, and it will results into I. I means identity matrix. And the other name of identity matrix is the normal form. So it is called the orthogonal matrix. A into A transpose is equal to I. Then it is the orthogonal matrix. So some matrices are left. We will continue the other matrices like nilpotent, periodic, idempotent, Hermitian, screw Hermitian, unitary, conjugate, involuntary matrix, equal matrix, singular matrix. We will continue in the next video. Thank you.